Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called A Pea-ory of Everything by Samu Piano and Sudoku. And here are the rules. Normal Sudoku rules apply. That is, each row, column, and 3x3 region has to contain the digits from 1 to 9 once each. Split pill arrows, P lines. The sum of the digits on a line strictly between two circles is equal to the concatenation of the two values in the circles in some order. For instance, let's see, there's unfortunately not. Say this was only 5 and it only had these three. We're just gonna make believe. Say so if this was, for example, 3, 3, 4, and 6, and this was 1, and I say this was actually here or whatever. This could be a valid split P line as 3, 4, and 6 add up to 13, which is 1 concatenated with 3. So one of these is the tens digit, and the other one is the ones digit in the split pill arrow or P line. The inner segment of each P line carries one of the extra constraints mentioned below. Although there are 6 different line types, each constraint follows standard rules. The bounding circles are never part of the inner line constraint. For example, when the inner P line is a German whisper line, which is this one, the circle digits do not have to have a difference of 5 to the next digit on the line. So each of these P lines must also fit another constraint. And this would be Nabner, this is modular, this is entropic, this is German whisper, this is region sumline, and this is Renban. And we will go through each one. Nabner lines. Nab gold. The golden line is a Nabner line. That is, on this line, there may not be consecutive digits. So a valid Nabner line would be something along the lines of, like, I don't know, 1, 3, 6, and 8. That would be a valid Nabner line because none of them are consecutive with each other. So that is Nabner line. Modular line, teal. So that's this long one. And remember, the circles are never part of this constraint. Actually, they're not even part of technically the P lines. They're just the endpoints. Every set of 3 adjacent digits along the teal line has 3 different remainders when divided by 3. In other words, every set of 3 adjacent digits along the line has to contain one digit of 147, one of 258, and one of 369. And if you have a number pad on your keyboard, you can just divide it into columns, and you'll see that's 147, 258, and 369 if you divide it by columns. So you have to have one of each in each set of 3 digits along the modular line. Okay, region sumline, light blue, this one. Box borders divide the light blue line into segments with the same sum. So basically, these 2 digits must sum up to the same value as these 2 digits. And that's region sumline. German whisper, adjacent digits along the green line, this is the German whisper line, must have a difference of at least 5. So for example, if this was a 7, this would have to be a 1 or 2 to make sure that adjacent digits have a difference of at least 5 along the German whisper line. Entropy line. ENT, orange, so it's this one. Every set of 3 adjacent digits on the orange line must include a low digit, 1, 2, or 3, a medium digit, 4, 5, and 6, and a high digit, 7, 8, or 9. So it's like the modular line. It's just that instead of dividing your number pad by columns, 1, 4, 7, 2, 5, 8, and 3, 6, 9, you divide them by essentially low, medium, and high. So you divide them into rows. So you have 1, 2, 3, 4, 5, 6, and 7, 8, 9. And you must have one of each in each set of 3. So that's entropic lines, or entropy line. And then Renban, which is purple, which was this line. The purple line must contain a set of consecutive, non-repeating digits in any order. So again, these have to be consecutive. So if you had a 1 on the line somewhere, you know there has to be a 2, a 3, and a 4 on that line somewhere, because you can't have repeats, and they must all be consecutive. So 1's only consecutive with 2, which is only consecutive with 1 or 3, which you already have 1, so therefore you have to have 3 then, and therefore 3 is consecutive with only 2 and 4, and we already have 2, so it has to include 4. So that you know then you would have to have 1, 2, 3, and 4. You would have to have 2, 3, and 4 if you had a 1 on the Renban line. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so for this modular line, every 3 sets contains one from, that's modulo 0, one from modulo 1, one from modulo 2. So this is a set of 3, this is a set of 3, and this is a set of 3, which means we know it's always mod 0. The sum of that is always 0 mod 3. I don't know if that's very helpful, though. Anyways, what can this Renban be? It can only have 1, 2, 3, and 4. What about this? Okay, let's think about the region sum. These two equal each other, so it's always even. But the thing is, the 10th digit could be odd. But you have to have at least one even there. Yeah, that doesn't really tell us much. Renban. If we so we tried 1, 2, 3, 4. That adds up to 10, which is not allowed for 2 digits. 2, 3, 4, 5 adds up to 14, which is also not allowed in the Renban because you already have 2, 3, 4, and 5 there, so you can't have a 4. 3, 4, 5, 6 is possible because it adds up to 18. Okay, so it could be 3, 4, 5, 6. 4, 5, 6, 7 adds up to 22, which is not allowed because that would be 2 2s there. So it cannot be 4, 5, 6, 7. 5, 6, 7. So again, 3, 4, 5, 6 adds up to 18. So this could be 18 there. 4, 5, 6, 7 doesn't work. 5, 6, 7, 8 adds up to 26, which does not allow because we already have a 5 and 6 there. So it can't be 5, 6, 7, 8. We already know it can't be 1, 2, 3, 4, can't be 2, 3, 4, 5, can't be 4, 5, 6, 7, can't be 5, 6, 7, 8. So what about 6, 7, 8, and 9? 6, 7, 8, 9's add up to 30, and 0 cannot be a digit here, so we know this is 3, 4, 5, 6 with 1, 8, and 1, 8. So therefore, this is 2, 7, and 9. This is an entropic line, so it has to have one low, one medium, and one high at least. So it's at maximum 3 plus 6 plus 9, which would be 18, plus 8, which is 26. So it's at maximum 26. It's at minimum 1 plus 4 plus 7 plus 2, which would be 14. So it's at minimum 14, maximum 26. So it could be 17, 19, 21, 20, can't be 22, could be 23, 24, 25, or 26. Interesting. Uh, this cannot have 2, 7, or 9. Obviously, if it's 21, the 3 must be the low. You could have 3 plus 4 plus 5 plus 9. That does work. Okay. It can't be 26. If it's 26, that would require 3 plus 6 plus 9 plus 8. Actually, can it be any of the 20? Yeah, you can never have 3 plus 8 plus 9. It would always have to be 1, I think, right? Um, these two must sum to each other. That means it has to be 15 at most. But really, it's only... Yeah, you can't have 15 twice because that would be 30, and that's not allowed. So this must contain a 1 or 2 also, right? On the ends. If it's in the teens, it cannot be 12 because then that would be 6 and 6, which is not allowed because that would have to include a 1, 5, and a 2, 4, so that doesn't work. 14 doesn't work because you have to have 7 and 7, and 1, 6, and 3, 4 are eliminated, so it would have to be 2, 5 twice, which just doesn't work. So it cannot be 14. What about 16? 16 eliminates 1 and 7 and 2 and 6. So the only possibility to add up to 8 on either side would be 3 and 5. So 16 doesn't work. We know 18 doesn't work because that would eliminate all possibilities for this cell. So it cannot contain a 1. Therefore, it must contain a 2. So one of these is 2. So it can't be 20, can't be 22, because obviously you have 2 digits which would be the same in the same row, which is not allowed. So it could be 24, 26, or 28. We're just not sure which. If it's 24, what does that imply? That means they're both 12. So then this would be 3, 9, and 5, 7, which does work. If it's 26, that means they both add up to 13. So it would be 4, 9, and 5, 8, which add up to 4, 9, which is 13, and 5, 8, which is 13. If it's 28, I don't think that works, right? If it's 28, that means they both add up to 14, which is only 5, 9, and 6, 8, which is not allowed. So this cannot be 28. So this is 24, in which case there's 3, 9, 5, 7. Or it's 26, in which case it's... So 3, 9, 4, 5, 7. Or it's 26, in which case it's 4, 9, and 5, 8. So either way, 5 and 9 are always here. Also, 4 is always in one of these. So we have 4, 5, and 9. This cannot be 4, 5, and 9. We know the 1 has to be one of these two. So it's 1. It could be 3, 6, 7, or 8. Okay. Interesting. Right. Okay, so let's, just make sure. So, if this was 24, this would have to be 3, 9, 5, 7, 3, 5, 7, 9, and this would be 1, 6, and 8, right? If this is 26, that means they're 13 each, so it must be 4, 9, and 5, 8, 4, 9, and 5, 8, 4, 9, and 5, 8, which means this is 1. And this has to be 3 and 7. Interesting. Huh. Okay. This is German whisper, so there has to be at least 2 lows and 2 highs. So German whisper always alternates between a low number, which is 1 through 4, and a high number, which is 6 through 9, right? Because there's a difference of 5 in between 1 through 6. So you always, if you're on 1 at the minimum, you always have to go to at least 6 through 9, right? So therefore, you always have 2 lows and you always have 2 highs. So at minimum, it's 1 and something, right? Maximum, it could be 3, it could be 4, 4 with 8 and 9, which would be 27. So this one has to have a 1 or 2 here. We're not sure which. I mean, it could have both too. Hold on, I'm gonna pause because I need to go to the bathroom. So I'll be right back. Okay, and I'm back. Let's just continue. So this has to have a 1 or 2. This also has to have a 1 or 2. Nabner lines. If you have 9, say you had the most, 9, 3, 5, and 7. What is that? That would be 3 and 9, 24 at most. So this is also 1 or 2. And it could be, yeah. If it is... So this is at most 24. It cannot be 23 because it would be... it would have to be 2, 5, 7, 9. It has to be at least say it included a 1. If it had a 1, what could this be? It would have to be 2, at least 2, 4, 6, and 8, which means it's 20 something. So it can never be a teen, right? Because if you tried to make it a teen, you have to have at minimum, you can't have a 1. So therefore, the minimum is 2 with 4, 6, and 8. That's 20. So this can never be a 1. So the 2 has to be here then. So this cannot be 1. It has to have a 2. So this can't be 2. So therefore, this is the 2, which means this can't be 2 at least. So this is 24 or 26. We know it can be 21. It could be 23 or 24. And 24 is the maximum because you have 3, 9 with 5 and 7. And that's the highest you can have with the Nabner line forming correctly. So you could have 24. 24 works with 3, 5, 7, 9. 23 unfortunately does not work because you need a 2. It has to be specifically be 2, 5, 7, and 9. So 23 does not work. 21 does work, though. What would it be, though? 21... Actually, no, 21 does not work either. If you try to have 21, the Nabner line would have to be 3, 5, 7, 9, which would add up to 24 anyways. So therefore, this is always 24. We tried to have a teen, it doesn't work. The only one that does work is 2, 4, is 24 with 3, 5, 7, 9. So this cannot be 4, it cannot be 20, so this has to be 26 then, which makes this 1 and 8. So this is 26, which means both of these add up to 13. So this can't be 1. This adds up to 13, so it cannot be 6, 7. It cannot be 5, 8. This one has to be 4, 9. So this can't be 3, 9. It can't be 6, 7. It's 5, 8. So this can't be 8. Therefore, this is 1, and this is 8. Which means this cannot be 1 or 8 or 6. So this is 3 and 7. So 3 cannot be here. So this must have... So this cannot be a... Can it be a teen? I guess it could be, but it has to be... No, it has to be with 2 or 4. And even... You would have the minimums 1, 2, 3, 1, 2, 3, and 1, 2, 3, which adds up to 18, which is not allowed. So it's either 21 or 41. And 41 is not divisible by 3. So it has to be 21. So we know this is a 2 and this is a 4 then. So this can no longer be 2. So it's 1. It's either 17 or it's 19. We know that for certain then because it cannot be... There's no 2. It can't be 3. So it has to be 1 and 7 or 1 and 9. This is 8. So this could be 2 and that could be, or that could be 1. One of them is 2, one of them is 1. We don't know which is which though. So modularity wise, this, so you can have at most, you have the minimum is 1, 2, 3, 1, 2, 3, and 1, 2, 3. That means you can have 1, 2, 3, and 4. Or 1. So basically, one digit can go up 3 numbers. So you have to have 1, 2, 3 in 2 of the 3 modularity lines. And the other one could be a 5, but then the other ones would have to be 1 and 3. Interesting. This cannot be 1, 2, or 3. Therefore, the 2 has to be here. And this one has to be either the 6 or the 4. Right? So 2 has to be one of these 2. Right? Okay, so we know in this box 9, the first 2 cells cannot contain a 1 or 3. So we need a 2, and we need a 4 or a 6 with it, because it cannot contain, it has to be modular, right? But it can't contain a 1 or 3. So this is 4 or 6. So this is the expanded one, which means 2 has to be one of these 2 because of the 3 in the modular line, right? In modular line, you have 1 of every modularity, or modulo. So 2 is one of those 2, so 2 has to be one of those 2. Can't be here, so therefore it has to be here. Because this one is the one that's increased by 3 in this one. So therefore this is 2, which means this can't be 2, which means this is 2. So this is 2, this is 8 or 9. This has to be 1 or 3. These are 1 or 3, therefore this is 2. And this has to be a 1-3 pair. So 3 cannot be here, right? So therefore this adds up to 6, this adds up to 6, and this adds up to 9. We know the 3 is here though, so this can't be 3. Therefore this must be 1, which means this must be 1, and therefore this must be 1, because it's every third one is the same set, right? Just because you have to have one of each set, these cannot be the same set as this, therefore this one has to be the same set as this, because you're missing that one. So therefore this is 3, this is 3, this has to be 6, I think, right? Because it's 0 modulo 3. Yeah, so this can't be 6. So this is 4 or 5, which makes this 3 and 6. This can't be 3, whereas the 3 in this column now, it has to be here. So this is 3, which forces this to be 6, which forces this to be 3. Okay, none of these can be 1, 2, or 3, yet there's a low here. So this one, the low here has to be 4, but it cannot be between two unique numbers. So therefore this has to be 4, which makes this a 9 and this a 9. This has to be low, it can't be 1, 3, or 4, so it must be 2. So this adds up to how much? This is 18, and we have plus 6, so it's 24. This can't be 2, so this must be the 4, and this must be 2. Okay. This can't be 4, so it must be 5, which makes this a 4. This is what? 3, 5, and 7. But 3 can't be here, and 5 can't be here. This must be 1, because that's the only place for it in row 6. So this is 1, which makes that not a 1, so that's an 8, which makes that a 1, which makes that a 9. This is an 8. 9 has to be one of these two, can't be here, so this must be 9, which means this is 3 and 7. This is 3, 6, or 7. Okay, we now have 3, 6, 5, 7, 8. So this has to be 5, 6, 7, 8. This is 5, 6, 7, 8. That can't be 8. This is 5, 6, 7, 8. This is 3, 5, 6, 7, 8. But it can't be 3. So where is the 3 in row 4? It has to be here. So this is 3, which makes that 7, which makes this 6. That makes this 3, and this is a 5, 7 pair. The 3 cannot be here. Okay, so this is 3, 4, 5, and 8. This can't be 3, obviously. This becomes, what is this? This is 4, 5, 7, 9. This can't be 4 or 9. This can't be 9. This can't be 9. So we know the 9 is one of these two. This can't be 4 or 9, so we have a 5, 7, 5, 7 pair in box 8. The rest of the box cannot contain a 5 or 7, so this is 4, this is 9. The rest of row 8 cannot contain a 7, so this is 3, and this is 7. So that forces this to be 3, 5, or 6. 3 can't be here, obviously. This has to be 1, 4, and 8. So 1 can't be there, obviously. So this is 4, 8. If this was 4, this has to be the same entropy. Which means it could be 5. If this was 8, this would also have to be the same entropy, but that's not allowed because it can't be... 8 doesn't have a corresponding one here, right? Because it would have to be 7 and 9, but they're both eliminated here. So therefore, this can't be 8. This has to be 4, which makes this a 5. So this can't be 5. This adds up to 9. We need a low here in one of these, but this can't be low. It's because 1, 2, 3, 4 are eliminated. So therefore, this has to be a 3. This must either add up to 17, which would require another 5, which is not allowed, or 19. So this has to be 19, with this being a 7. So this can't be 5. This can't be 5. This becomes 6 and 8. This 5 eliminates a 5 here, so this becomes 8, which makes this a 4 and makes this a 3, which makes that a 5. These can't be 5. This can't be 7. So the 7 has to be one of those two in row 4, which means it has to be those two in box 5. So this can't be 7. We're looking at 6, 8, and 9 here. This can't be 9. This can't be 9. This can't be 4. So this is 2 or 7. It can't be 2. So this is 7. This is 2. Which means this can't be 7. Where is the 7 in box 1? It can't be any of these, so therefore it has to be here. So this is 7, which makes this a 5, which makes that a 9. This becomes 4 and 5. 2 cannot be here. So where is 2 in column 4? It has to be here. So this is 2, which makes this a 6 or 7. Also, we know this can't be 9. So this is 4. This is 9. That 4 makes this a 5, which means that can't be 5. So this is 4. This can't be 5. So that's a 7, which makes that a 5. So this is 2. This can't be 7. So it now has to be 6 or 7. So therefore it's 6, which makes this a 7. No 7 here. This can't be 6. This can't be 6. So therefore this is 8, which makes this a 6. This is only 1 left. And this has to be 7 and 8. This can't be 9 anymore, therefore this must be 9. This can't be 5, so this is 6, which makes this a 5, which makes this an 8. Which means that can't be 8, so it's 6. This can't be 1, so it's 8. This is 1. This can't be 8, so this is 5. This can't be 5 or 8, so this is 6, which makes that an 8. Which makes that a 7, which makes that 8. This is all just normal Sudoku. That's a 7, and this is a 5. And that's a solution. Fairly straightforward, actually. Yeah. Not very difficult, actually, I thought. You just have to go through the right order, right? So you basically have to figure out the Renban, because you can't... None of the Renbans work except for 3, 4, 5, 6, which limits things here. So it had to be 24 or 26. The Nabner line was very limited too. So it could only be 24. So that limited this to not be 2 or 4, which makes that 2. And that limits that, which made that a 1. Yeah. So, yeah, it's all about figuring out what limits things the most. And it's pretty straightforward. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.